So let's get right into it. The job here, it's a reconstruction, and if you see this PowerPoint, you'll see that we've got existing buildings on the left and right side of this, and they're heritage, so they can't be changed. So effectively, the left and right edges of our footpath are actually pinned to existing areas. There's then a constraint on how much the footpaths can slope. They obviously have to slope towards the road for drainage purposes, and then the idea is to take that and somehow make the road work and optimize the cut fit required to make it happen. So the reason this becomes a challenge is that normally you kind of design from the center line towards the actual edges of the road, whereas in this case we're doing the opposite. We're starting on the edges of the road and moving inwards towards the center line, which is actually not that difficult to do once you kind of set it up, but it's because we're so accustomed to working in the opposite direction, we kind of tend to overlook it. So this is the little graphic that we showed on the invitation, and essentially what we want to do in this case is, let me just bring up my drawing tools. So we want to keep this area here pinned. As the arrow shows, we want to raise up the inner edge of our footpath. Now what can often happen is that that will obviously draw a line to here, but it will sometimes just stretch to the previous point, which in this case is the face of our curb, which is not what we want. So what happens in this case is that the curb actually lifts up, as I'm highlighting here, which is perfect. Then the road moves back towards the center line. So we're literally picking the levels of our footpath and having that move back onto our center line. What we then do is adjust our center line elevation. So I'll show it on the last section here. Say I lower my center line elevation. When that happens, it basically stretches the road down like this to match. So we use a bunch of constraints to work the system that way. So as long as you understand that this here is what we're aiming towards, the webcast will make lots of sense. So how we're going to just show this is just quickly show how you pin points to natural surface, which will be the edges of our road. Then we'll just go through reference planes very quickly and just show a little bit of string design. Then get into the heart of it, which is how you design from the outside in. We have the finished job to show at the end as well. So let me just jump into the software. So I've got a few files saved here just to save a little bit of time. So what this one is just a very simple natural surface, just with a few lines and strings set up. So I'm going to make an alignment from my center line, which I will call CL, and I'm going to make an alignment from the left edge. So I'll call this left. Alright, let me just check everything's going okay here on the recording. So people are asking how the weather is doing. Yeah, it's very warm in West Australia. If the audio isn't good or something, just send me a message on the questions. I do have the questions panel open at the bottom of my screen. So I've got my two alignments here. What I'm going to do now is bring in my assemblies. So I have my basic road here. Now in this case, we don't really have batters because we're going straight to our surfaces. So I'm going to take those ones off. And the footpath is not really a standard footpath either. So I'm just removing those two sides. What I'll do is go to my generic link, do a link width and slope. So in this case, I'm going to the right side. So I put that one on here. And I'll do the same for the left side. So I'm just using a generic link for my footpath. There are other ways to do this as well. Most of the assemblies allow you to override. So I'm going to select this object, go to my sub-assembly properties, and change the name of it to footpath right. So it is very good practice to name these properly. I'm probably the worst person for not doing it because usually I'm just showing a demo. But if you're doing serious work, don't forget to rename them. So footpath left and footpath right. What I do now is select my alignment, go to corridor. Actually, let me first of all build my surface profile from it. So I'll say add profile, draw profile view. So on my center line, I will go and do a design. Now, I've gone pretty fast there, so your screens are probably catching up. I've just done a profile of my center line. I will create a design here. So I'll make sure we've got plenty of cut and fill happening here. That's my design center line. Now what we're going to do here, let's just do it in stages so we can see exactly how it works. So I'll show two viewports. So these lines here are my strings where I'm holding my mouse right now. The two green lines, one is natural surface and one is my design profile. Just as we're doing this, if you watch the upper green line, if I select my design, you can see it's become dotted if your screen's updated fast enough. And if I now go and change this, you will see the actual string updating on the bottom. So you can see exactly what the software is doing as we kind of build these corridor models. So what I do next is I select my alignment, my center line, and I build a simple corridor. So it asks me for a profile. I select my design. It asks me for a cross-section. I pick this one here. I just press OK to begin with. So that's all good. That's my corridor here in the bottom. What I now want to do is pin that footpath onto the edge, which is my existing kind of building line. So I select that building line alignment. And the point I want to make here is that you go to surface profile, you press add. So let me just wait for your screens to catch up. You press add, so the surface gets added to the bottom here. You don't have to draw it. I press OK. There is now a profile of that surface. And you can see that green line has appeared on the bottom, which I'm just hovering over now. So all I do is select my corridor model, go to Edit Targets, pick my chainage range, which in this case is the entire alignment, and it asks me to select which items are which. This is where your naming convention comes in. So you can see that we have width and slope. So basically, the first group is my horizontal, second group is my vertical. So I go to footpath left, and I select from here. You can do alignments or feature lines. So we'll do alignment first. I know mine is called left. I could also go and grab it, clicking my select from drawing button. I'll just press left. Don't forget to press the add button here. It's a very easy one to miss. You press OK. Now that just takes the horizontal. It will continue at its existing slope. What I now do is go and press the actual profile. So I select left from here, click the natural surface I just sampled, press OK and OK, and you will see that my corridor model is now snapping to my surface on the left edge. So your screens mightn't be able to catch up with this, but if I spin this around in the object viewer, it becomes very obvious what's happened here. And that's just a standard corridor model, and all you're doing is draping a string to a surface. It's a pretty simple thing. So one variation on it, which is quite interesting, is you don't have to use alignments for this. So just to show the other method, I'm going to go back to my plan view. I think your screens might be catching up a little bit here. But I'm going to click on the string below here, and instead of making an alignment, I'm going to make a feature line. So I go to Home, I go to feature line, create from objects, select. So somebody's asking, is this only on 2011? That's Dave Grocott. No, it's on 2010 as well. The actual movement to alignments and profiles has been there for probably 5 or 6 years. What I'm showing now is just 2010, I think. I'll have to verify that. So I'm going to make a feature line here. You should name these things as well. I'm going to call this right building line. So I press OK. I've now got a feature line here. So what I can do now is the exact same process, but I don't have to create alignments and profiles. So I go to my corridor properties. I go to my, actually I'm doing this the old way. You go to corridor properties, parameters, and set targets. And you get this dialog box just showing up here, which I'm going to cancel and do the quick way. So you should now see that. I think the connection here mightn't be the fastest, but what you now see is the map targets dialog box. On 2011, you can get to it in a much quicker way. So you highlight the corridor model, you press edit targets, and you always pick your change range on plan view in case you've got multiple baselines set up and stuff, and it brings you straight to that dialog box. You just bypass a few clicks. So what we're going to look at this time is the footpath right mapping. So I picked the exact same option. This time, instead of picking alignments, I select feature lines. Now you'll notice it says feature lines, survey figures, and polylines. So if you've done a survey, you can snap directly to your survey string. If someone's got polylines, you can snap to that as well, or you can draw polylines. So I press select from drawing, and I click that one we just made. Press OK, and you can see that the name of right building shows up here. That's why it's good to actually put the name on, just so you can be certain you pick the right one, especially if you've got survey feature lines and design feature lines. A good naming convention just helps you keep things moving. That takes care of the width. We now want to go and do the same thing for the elevation. So you click on feature lines again here, select from drawing, pick the same one, and that's added in here. So we press OK and OK, and the exact same result happens. So if you look on the bottom of the screen, you will see that the two footpath edges are now draped onto the natural surface. So I just want to make sure everyone's aware of the fact that you can do it with feature lines as well as with alignments and profiles. With feature lines. So what you could do is, after you've done that, do a typical cross-section and drape each component onto the relevant string. And the benefit then is that you get proper cross-sections and everything. So we'll show that a little bit later on. So first of all, that's the first message. You can just pin things onto natural surface. Now, let's do something more ambitious. So I'll open up my second drawing here. So that's all well and good. We're working from the inside out, like a standard. Start at the center line, work towards the edge of your road, and then work towards the footpath. What we now want to do is reverse that completely. So what I've got here is kind of a finished version of what we're doing now. This is basically a center line, which you can see the mouse hovering over right now. And I've got the edge of my road here with the curb and gutter, and I've got the lane hanging off that. So just to show how this works, I click on my center line here. Let's leave this off for catch up. I go to corridor. It asks for the profile, so exact same as normal. Press my center line profile. I've only got one assembly, so I pick that. So I think your screens could be lagging here. I'll just do this quickly so you can see what I'm getting at. There's two targets to set, and they're both done by alignment. So what I'm effectively doing is offsetting to the left, then offsetting back to the right. So what I've done here, I'll actually pause at this when I've completed this one, and I'll show you exactly what's happened. So what I've done here is I have told the software I am adding my corridor model to the centerline string, which is the one you can see the changes on, but I've told it to snap to the edge of the road for my curb and gutter. So if I take this and open the object viewer, actually that's going to be too slow for your screens. Let me do 2 viewports instead. And in this one here, we will take an orbit. So let me just spin this around and I'll stop moving so your screens stay fixed up. So when your screens catch up on the bottom screen, what you will see is the blue string that my mouse is on the end of now. That's my center line. On the right hand side, that is my curb and gutter. So we've offset that curb and gutter, and we've now got the lane hanging off it. Obviously the lane is stopping in no man's land. So the next thing we do is go back to the corridor object, go to edit targets again, and you can see my left lane here. Now I've named it left lane from curb to CL, just so we understand what it's doing. We go and we stretch that back onto the center line. So you press width and you select center line. And for the profile, exact same thing. So we select profile, center line, design, add. So what we've basically done is we've stepped from the center line out and then come back onto it. You press OK, and that's now stretched back onto my center line. Now what this means is, if we go back to the PowerPoint, let me just clear this drawing I was doing. So what we've done here is we've switched the focus onto this string here that I'm just drawing on. We have used the profile to raise that, as we're showing here, and the curb and gutter has come with it. The lane was attached to that, but the width was just like 2 meters, it was random. So we've now stretched that back onto the center line. So it's a bit weird when you first see it, but it actually works very well. So what I'll do here is I'll do it from scratch so you can see exactly how it works. But just before I do that, I'll go and make some changes to my designs. So on my left profile here, I'm going to go and make some changes. So I'll go to my corridor model here. So on the left of my screen, I've just highlighted the corridor, so it's called corridor-2. I should rename that. I'll call this offsets. So basically when I make this change, the offsets is going to give me a warning message saying you've done something. So I'll take this, I'll raise my left string way up. So you should see 2 things happening here. On the bottom screen, my dotted green line shows what I've done, just where I'm hovering my mouse now. That just basically gives you an interactive view of how you're kind of interacting with your strings. On the left-hand side, the corridor offsets is needing to be updated. So you right-click and you rebuild, and that updates for you. Very simple. Now, let me just zoom in and show what's different about this, because you could do a very similar thing just using the edge of the road, but in this case, we're not playing with the edge of bitumen, we're playing with the back of the curb. So I'll do it once more, and the dotted green line should show us what's happening. So I'll raise this up some more, I'll drag it along. Oh, sorry, my curve radius is too great, I can't do that. Okay, now let me adjust that one more little bit. Okay, now on the bottom screen, if you look at that green line, I'll just draw a normal AutoCAD line to show you what we've done here. Basically, we have raised the back of the curb up by that distance that I've just drawn. So you should now see the highlighted line, which is just illustrating what we've done. I'm going to move that. Normally what we would do is raise this line here and project outwards. We're working from the outwards inwards. but that's the real point we're making here. So now when I right-click the corridors and rebuild, it first of all drapes the curb on, and then the footpath, then the lane travels from the curb back towards the center line. So let me just show how that was set up. This is the finished assembly here on the top, and it's actually not that difficult to do once you've seen it happen once or twice. You go and build yourself a standard assembly, and what you do is use the generic link called width and slope, which is on the generic tab here on the right hand side. So some people have always asked where these come from. You bring up your tool palettes, which you press on the ribbon here, and on the tool palettes you set your group to ANZ content, which I'm hovering over now. So just by right clicking on the name, and on the ANZ content you press generic links. You press link width and slope. On the properties you can go and specify left or right, etc. And I'm going to give a width of, let's say, 12 meters, just to give us plenty of space. That draws this line here for us. So that's going to be our offset from the center line. I'm just going to draw an AutoCAD line here as a kind of a reference point. So what you now do is you attach your curve on here. So you go and press, we'll go for a quick reference. You'll see urban curb and gutter general. I'm going to make a mistake here first and then correct it. When you attach this curve, it always attaches to the obvious inside out kind of point. What we want to do is change that. So we select this curb subassembly. I'm going to right click, go to my subassembly properties. Again, I should rename that, but I won't. Now there's an option here saying insertion point, gutter edge, or curb back. What we're after is curb back. Now strangely, when you switch to this curb back, it flips the actual curb and gutter. So what I should do is change it from left to right. I'll just not do it first of all to show you what happens. I press OK, and you can see it's picked the back of curb, but it's flipped the wrong direction for me. So I select that again, go to my subassembly properties, and just change the parameters from right to left, which is a little bit illogical, but once you know it and just use it, it works fine. So now it's behaving as it should. So we have now picked that as our reference point, the back of our curve. So the next thing we do is click on a lane. So I'm clicking lane inside super, which is the one I always use. Now in this case, even though it's on the right, we're moving towards the left. So once again, you reverse these. So moving to the left from the right. The values for width and slope don't actually matter because you're going to change these with the string anyway. You attach that onto here. So that's more or less our assembly. You would then go and build your footpath, etc. afterwards, which I'm skipping for this. But that's more or less what you do. Now what's going to happen here is that when you plot your cross sections, you're going to have this generic link showing what's happening with the initial offset. So the last thing you do is select that and turn the visibility to false. So you can do it by right-clicking and going to subassembly properties, or on the AutoCAD properties now, which I've got on the left side of my screen. It shows you all the options. So you will see omit link, no and yes. So when you press yes, what it does is it keeps the link, but it doesn't show it on the cross sections. So it's now effectively frozen, and we have basically achieved the offset to work from the inside out. Sorry, from the outside in, based on that one little trick. So that's more or less the kind of bones behind the whole thing. You take that concept and you basically mirror it from left to right and add it to the two edges of your road, so your footpath and your edge of bitumen. So the only other thing that you would do is put on some design constraints just to show how you project grades and that kind of thing. So what I'll do here is I'll go back to a single viewport. I'm actually going to erase these two. So our corridors will be gone. So that will take care of the actual mechanics of the assembly itself. The next thing you're going to want to do is grade the strings correctly. So the first thing you can do quite easily is project one profile onto another. So let me just show you that in case you haven't seen it. I select this profile here of my center line. I want to project that onto my left edge profile above it. So you press the option on the ribbon, which updates, called Superimpose Profile. So you hit that, and it asks you to pick your profile. So I pick my left profile here. It asks me some questions, which I'm going to ignore, and it superimposes that profile for me, which is very useful. But the limitation is that it's just doing a straight grade projection. You always want to project it at a certain crossfall. So I showed this briefly last week, but the webcast got a bit confused with bad web connections. I'll do it here very quickly again. In the standard assemblies which come with the country kit, there's one called Reference Planes A and Z. So I bring that in, which is literally just a bunch of lines going at certain grades. Now they've been named quite carefully so that you always have the 1% called 1%, etc. So the next thing I do is go to my center line, build myself a corridor, exact same as previously. So you build the corridor, you pick your profile, and you pick your cross-section assemblies. Now in this case, targets don't matter, so you just press OK, and it builds these for us. I'm going to cheat here and make sure that my two profiles fit inside that range. You'll obviously be more careful, really. The next thing you do is pick that corridor, and you go to Corridor Surfaces, which is up here. And what we do here, what I used to do in the past was create a surface, and you have your 1% crossfall, your 2%, your -1, your -2. I used to go and add each one individually, but then someone showed me there's a much quicker way. So let me just position this. You press this button here, and it makes one for each corridor surface, sorry. So all you have to do now is go and name these correctly. So this one is +3%. This one is -2. This one is -3, +2. Just finish these off. -1, -1 left, +4, -4. I may have got some of these wrong. I'm not paying a huge amount of attention to it. I'm just chucking them in. Actually, I think that one is +1. So you get the idea. So you press OK, and that builds a bunch of surfaces for you. Now all you have to do, now I've set those surfaces to no display because you don't have to see them, just know that they're available. So what I'm now going to do is pick my left string here. So if you watch the profile view on the top right of the screen, I select here and click on my surface profile option. And all I do is add these surfaces to it. So I press Shift and highlight +1 to -4. Press the Add button and basically pick the correct styles for each of these. So click on the 1% and set that to surface 1%, and you got 2% here. Now somebody made a very good comment about this last week, which was about how the layers work. So let me just finish this very quickly. So I've now picked correct styles from my 1 to 4%, and all I do is press OK. A previous kind of misconception was that you had to redraw the profile view by pressing the Draw button. Once you press OK, that information gets added to the profiles, so you can now see on this view here the different colors corresponding to 1 to 4%. So you would then take your profile view and make sure that you fit within that range. Now, the comment that was made last week, I was just showing how you could change the kind of aesthetics of these projections. So you could go to your profiles, go to layers, long section profiles, and under profiles you have these entries for reference planes 1 to 5%. Now the comment, which is actually very obvious once you think about it, was that what you can do is turn them all off and just turn on the one you're interested in. So if you're only working on the 2%, work off those ones only, which is very valid. I was discussing that with some other people since, and they mentioned that they also like the fact that instead of using layers for that, you can press the profile view, go to profile view properties here, which is just catching up on your screen. So I've right-clicked and select profile view properties. The fourth tab here is profiles, so you can actually turn these off individually. So if all you care about is plus 2% and plus 1%, you can turn just those two on without using layers. So you press OK, and you have that plus 2, plus 1% option. Now the only danger here is that if you're using both, you may forget which one you've done. So you may start changing the layers, forgetting you've turned them off on the profile view itself. So as long as you're a bit careful with that, you should be pretty okay. So that's the concepts. Using the generic links to work from the outside in, and using reference planes to pick the grades. So with that, let's just bring up the real job itself. So what this is a kind of a nearly finished version of it. So you can see we've showed contours with slope arrows, so you can basically illustrate very carefully how the system works. Obviously you're grading from your edge of your building onto your curb and gutter, and from the center of your road also onto the curb and gutter. Now for this version, I'm only using one cross-section. So if you look here, I've got my cross-section line on my left-hand viewport, and I can select that and drag it to whatever change is relevant. So as I do that, the section view on the right-hand side updates for me. So that's how I was checking it based on this. The real kind of mechanics happens in that, let me switch to a single viewport so you can see what's happening here. I'll just minimize a few of these panels. So what I'm showing here is the left edge, so my first kind of offset, and the yellow line is a 2% projection of the edge of my building. So I know that if I kind of bisect that as best I can, I'll be more or less right. Now because it's the edges of buildings, you can see it's quite jagged, so we don't have the flexibility in this case to regrade it. They're heritage, so you can't touch them. So you basically have to make sure your crossfall corresponds to something similar. So actually, I'm going to switch back to two viewports, having just changed. So what I do is I show the cross-section updating as I move these. So let me just get my screen set up here. Now I'm just moving quite quickly here, so just bear with it, and when your screens catch up, it'll all be set. So what you should see now is the left edge profile on the top of the screen. On the bottom is the cross-section at chain edge 40. On the left-hand side, the thing to watch is my Recon corridor model. So as I make changes, they're going to update for me. So chain edge 40 is here. So what I'm going to do is click this string. So the yellow line is 2%. So if I drag it just to here, I should be at more or less exactly 2% now. So if I zoom in to my road, if I right-click the Recon, it's on Rebuild Automatic. So you can see I'm on more or less 2%. If I go and bring it way below that, they will update for me as well. So basically that's how you design your left string. You do the exact same thing for your right hand string, which is over here. So you select, and again you've got your natural surface in green and you've got your projected in yellow, so you basically do some logic based on how you want to work that one. Now what's more interesting is for the center line. In this case you got a constraint for both sides of the road. So what I'm showing in this case is the cyan line. Let me just press escape so you can see this. The cyan line is plus 2% from my right lane, which you can see where I'm holding the mouse now on top of the screen. And the yellow line is 2% from the left lane. So I know that if I basically keep this more or less in between the two lines, my system will make some sense. I'll be around the 2% mark. It's pretty obvious in some places, so where I'm zoomed in now, there's an obvious solution. As you move on the road, it becomes more ambiguous because the crossfalls change. But this gives you a very good first pass at your design, and you can then go section by section and improve how it looks afterwards. So we will be able to give this drawing out. We've shifted everything around so that no one knows where it is and that kind of stuff. And you can just see the logic and how it works and everything. So the last thing we've done with this, let me just, I've got a finished version I can jump to in a second. Let me just start doing it to show you how the logic works, and then we can switch over in a second. So in this case, I've got one single cross section, which is my kind of random one. What I would do next is build a cross-section sheet. So I go to my Home tab, I select Sample Lines, and I click my Center Line Alignment. So because I've built cross-sections already, it wants to add the new ones to the same group. So what I do here is create a new Sample Line group. And as usual, it's a good idea to name these things correctly. So we don't want to show all of our reference planes. All we want to show is our two surfaces. So we go put the surfaces on, put our corridor on, and I will call this 10-meter chain edges. So I press OK. And I'll tell the software here I want to do my cross sections by range of stations. And what I want to do here is go every 10 meters. I want to skip to start at chain edge 10 because my first few meters are a bit messed up. And just press OK. That's my new cross-section range here. Now a message has just come in saying I was updating the wrong thing, which I think is actually correct. Let me go and put my viewports onto 2 horizontal again. Just give me 2 seconds here. So let me switch to my corridor, zoom to it. What's been pointed out quite correctly is that as I've been raising these strings, I should have been rebuilding my corridor model, not my surface model, which I absolutely agree with. So I right-click, press rebuild, and the cross-section now updates. So you can see I've gone to 5.6%. So in here, if I select this and move it down, so it's more or less on the yellow line, right-click, rebuild. Now you can see that we've got 2%. So that's basically giving you the guideline on your profile view to stitch these up. So you basically set these up as many as you want. So we'll do the same thing for the right-hand side here. So we're currently at 2.9%. So you would pick this line, and I mean you can't get it totally perfect because there's limits to constraints. You right-click, you rebuild, and you got 2.1% here. So you use this to make the best kind of engineering judgment you can do, and away you go. So yeah, that was a mistake on my part. It's good that people spotted it. Now, what we've done next is we've made these 10-meter regular cross sections, which you can see here. I'm currently working at a scale of, we'll say, 1:200. Now you don't have to do these cross sections in the same drawing. I'm doing it in this case because this is a very simple little 100-meter road. If it was a longer road, you could X-ref out to a different drawing. But just for simplicity here, I press one of these cross sections, and what I normally do is create a single section view just to show the random cross section we saw earlier. In this case, I'm going to create multiple section views. So I do this. I'm happy with 2 times vertical exaggeration. Obviously, you can pick more. Actually, let me just do one more thing quickly here. Before doing my cross-section views, I'm going to sample some volumes. So there's an option here called Compute Materials. So I press that from the ribbon. I pick my sample line group, which is 10-meter chainages. Press OK, and I click on Earthworks. Now there's a bunch of more complex options, which we'll do some other time. In this case, I say my ground is my existing, and my datum is my design. What I should have done is made a surface of my datum design as opposed to just the top. But to show the concept, this is good enough. I press OK. I now have cut fill volumes. So I can show those on the cross sections. That's why I cancelled out. So once again, I go to Create Section View and create multiple section views. So as I said previously, you press 2 times exaggeration. You can give some names here, which I'll skip. You go to Next. And the important thing here is to pick your template. So you press this button here, and you click. Your template's probably selected previously. If it hasn't been, you press this ellipsis button, and you browse to Planned Production, and you've got a template here called 2011 Section Sheet A and Z. So when you press that, you can pick which scale you're working in. So we're going A1 at 1:200. We also have some other options for different sheet sizes. But let's stick with the A1. You go Next again. Offset range is fine. Elevation range is fine. On section display options, you decide how you're going to show your corridor object. So the one I've been showing previously has been this one I'm holding over the mouse over right now, which is A and Z, cross-section plotting, labels, and full assemblies with hatching. Now, the hatching looks great on demos. You might not want that on your plotting. There's one below it called exact same name without hatching. There's one below that called top links only. There's also one called labels only. The idea of the labels one is that you show the actual geometry through the surface and just put the labels from the corridors because they give you more control. So let's just put on the hatching one just because it looks nice on the screen, but I want everyone to understand that you don't have to use that one. On the design surface, you also put on the style you want as well as the labels. So the labels are after here is the ordinate lines, which basically draw the lines from the corridor object down to the bands. Last step is the bands themselves. So you still have to go and do this irritating step where you tell the software which surface corresponds to which area. So S1 is design and S2 is existing, which you see from where the mouse is hovering now. So on S2, you go to existing. What I do here is double click and press E for the first letter, just to save a few irritations. And the very last thing I'm going to do is go to my section view tables. So in here, it's going to add the cut fill volume at each cross section. So you've got a few options here for material volume and total volume. I'll pick a kind of a simple version here. You press add, and when I create my section views now, I'll just zoom out here. So I've clicked the point, and it's now putting them in. Your screen should catch up in a second. So it's basically spaced the corrections onto the sheets for me, and it's put in the volume table on the right-hand side. So they can also show up on the long section. I'll do that just before we finish. And you can do math hall diagrams in various reports. So one more thing you can do here before I forget to show it is if I go to my Analyze tab, you'll see Material Volume Table and Total Volume Table. So I'm just holding the mouse here slowly so the ribbon should highlight on your screens. I press Total Volume, and again I'm skipping all the parameters. When I press OK, it makes a chainage by chainage volume for me. So I can go and actually work out where the logic is coming from. You can always do a surface volume comparison, but by doing it this way you can basically see if it's doing it correctly as opposed to having just one simple answer. Now I want to do one more thing here. I want to go to one of my cross sections, so I'm panning quite quickly here back to the plan view. So go to this cross section and I click, in this case, chainage 60, and I'm going to widen this significantly on both sides. So what's happened here is up on our plan view, up on our section view, chainage 60, where the mouse is now, is starting to encroach on its two neighbors. So all you do is select these kind of guideline sheets, these green and yellows, and you'll see a button on the ribbon called Update Group Layout. So you press that, actually to pick the ones you want to work with. You press OK. Actually, let me do that again. I think you have to press the actual cross sections themselves. So Update Group Layout, highlight all the sections, press OK, and it respaces them for me. So that's quite a useful option because on Reconstruction, the positioning and the spacing of the sections and everything is something that you kind of have to pay quite a bit of attention to. So the last thing you do here, you save the drawing first of all. A feature of 2011 is that you can put these into separate tabs. So I go to my Output tab here, and you see an option called Create Section Sheets. You press that, and it reads the scale you specified when you made the sheets. So I hadn't done this in a while, so when I was preparing yesterday, I was looking here on this dialog box to specify the scales. The scales are specified when you go and create the sheets. So you press Create. It's warning me my drawing is going to be saved. Okay, there's a good question here saying, can you turn band labels off for sections except the first one on each sheet? Yeah, I see where you're coming from. This is the typical section kind of view. It doesn't have an option for that specifically, but you could turn them off for everything and just go and manually turn them on for each first section. So let me just finish this and I'll come back to it. So this is my section sheet here, which is now in a proper drawing kind of a template. It puts in the drawing numbers and that kind of business for me. It puts in the scale, 1:200, and when you go and look at the sheet, look at the actual section spacings, they're all set up. So the question that was being asked was, could you go and just have the correct versions showing up? What you could do is pick this section view and go to your section view properties for this particular section. And you could tell it that for the corridor, the style you want to have is going to be, say, no labels. So you would set them all to be no labels and just override the ones that you want, which isn't the perfect answer to your question, but we'll look at a more automated way of doing it for the future. So the last thing that you could do if you wanted, we won't have time to do it now, but if you press this section view here, this long section view, you can change profile view properties, put on bands, and if you change it to ANZ roads all bands, which I'm just hovering the mouse over now, you press OK, it puts in a bunch of things, including ANZ volumes, cut, and fill. So you must tell it which two surfaces to use, of course, and which sample line group, etc., which we mightn't have sampled here yet. But so I haven't put them in here, but you can set it up to put these in for you. Now again, I can send you a sample drawing with that, so you can see the results of it. But the important point here is that using that, you can quickly design from the outsides of your roads back in towards the center. There's quite a few variations where you do outside, left and right, and a bunch of things. But once you can do the simple version here, you can do the more complex versions quite easily. So that's the main gist of the presentation. Finished job just been done with cross sections, etc.